Transpose of a matrix, it is obtained by interchanging the rows and columns of a matrix. A matrix of the dimension A of mn's, transpose will be another matrix of the dimension B of nm. That is, row becomes the new column and column becomes the new row. For example, a matrix of dimension 2 by 3, that is 2 rows and 3 columns, after transpose it will become 3 rows and 2 columns. Let us see the program. So this is your original matrix, two-dimensional matrix. Then the new matrix, the m and n are the number of rows and columns respectively. The loop variables i for rows and j for columns. Now number of rows m and number of columns n. You are reading the elements to a 2D array. Now you are going to interchange the rows and columns. So now the new row will be the columns, number of columns of the first matrix, and the new columns in the second matrix will be the number of rows of the first matrix. Now the new matrix B of ij is formed by interchanging columns and rows. So ji. Now after the execution, by the time this loop is completed, the transpose will be over. The new matrix will have the number of rows as old matrix number of columns and the number of columns as old matrix number of rows. So here is where they have displayed the output after transposing the matrix. Square matrices. A matrix which has the same number of rows and columns is called a square matrix. It has the order n, which means the rows and columns are same. So you can perform, this is an example for square matrix where the number of rows and number of columns are same. So here this is the main diagonal and this is the off diagonal. So main diagonal, off diagonal of a square matrix. So main diagonal is also known as principal diagonal. Similarly, off diagonal is also known as alternate diagonal. The sum of the row and column subscripts of these elements will always be n minus 1. When the matrix is in odd order, it will have a common element coming in both the diagonals. Now the program to read a square matrix of dimension of order n and display the elements of principal diagonal. So principal diagonal means you have both. So suppose this is your matrix, square matrix with the number of rows and columns as same, 3, 6, 8. This is the principal diagonal. If you look at the row and column, this is 0, 1, 2. This is 0, 1, 2. So all the diagonal elements are lying at position 0, 0, 1, 1 and 2, 2. So a for loop which will go from 0 to n, you can just display I. That is 0, 0, 1, 1. 0, 0, 1, 1 and 2, 2 are the diagonal elements. Or alternatively, you can use the expression if I equal to j, because 0, 0, 1, 1, 2, 2. So when I equal to j, you will get the diagonal elements. Now off diagonals, to display the off diagonal elements. So again your matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the off diagonal. These are the positions 0, 1, 2, 0, 1, 2. So these are the elements at the off diagonal position. So you will get the elements in the off diagonals. This is for reading the elements. To display the alternate diagonal, it is n minus 1 minus I, or alternate logic is if I plus j equal to n minus 1. Say for example, this one, this is I and this is j, and the size of the array here is 3. So 3 minus 1 is 2, so 0 plus 2, 2. Similarly, this element will be at positions 1 plus 1, which is 2. So that also, then this is at position 2 and 0, so 2 plus 0 is 2, that is n minus 1 is 2, which is correct. So you can either display the off diagonal by using the formula I plus j equal to 1, or you can go for a of I n minus 1 minus I. So that is 0 and n minus 1 is 2, 2 minus 0 is 2. So 0, 2, this is the element. 0 to position, this is the element. Then 1 and n minus 1 is 2, 2 minus 1 is 1. So 1, 1 position is this element. And similarly, when it is 2, n is 2, a of 2 and 3 minus 1 is 2, 2 minus 1 is 0. So this is this element. So either you can go for this method or you can go for this method to display off diagonal or alternate diagonal elements. Sum of the elements of the principal diagonal, same method to find out the principal diagonal. Either you can use I equal to j or a of II. So S is equal to S plus a of II will display the sum of the diagonal elements. If you are writing if I equal to j, then you will be writing, so there you need a nested for loop, and then you will be writing S is equal to S plus a of ij. So nested for loop is required in that particular case. Next is sum of elements of both diagonals. So you have the elements coming from I will display the principal diagonal, a of I of n minus 1 minus I will be displaying the off diagonal, which is same as using the nested for loop, and then you will be writing I equal to j or I plus j equal to n minus 1. So either of these methods to display both principal diagonal and off diagonal, either a of I or a of I of n minus 1 minus I. Next is avoiding duplicate values in your sum. So to avoid duplicate values and using the second method, it is n minus 1 minus I equal to I. Then you will be finding the sum of only the diagonal. All the other cases you will be finding the sum of both diagonal as well as off diagonal. So this is like avoiding the duplicate elements. Then this is square matrix. You have upper triangle, which is represented with I less than or equal to j, and a lower triangle, which is represented using I greater than or equal to j. So this is where you have the upper triangle elements being displayed. I less than or equal to j, upper triangle elements are displayed. Sum of upper triangle elements being displayed. Then this is one program on page number 372 of Sumita Arora's book. Print elements except diagonal elements. So where instead of writing I equal to j, I not equal to j, and I plus j not equal to n minus 1, when it is other than diagonal elements when you display the values. Or second method is like this. You will display a space. All the other cases you will display the element. Few examples of array programs. Middle row, middle column. To print the middle column, this is to print the middle row. all the elements of middle row. This is to print all the elements of middle column. Sum of values ending with 2. Divisible by 10. Display elements at the odd position. Display alternate elements.